So let's discuss large sample confidence intervals for comparing proportions, and this is going to take a couple parts. So to obtain a confidence interval, we replace the population proportions P1 and P2 in the standard deviation by our sample proportions, right? And then the result would be our standard error, right? When we're working with means, it's the sample standard deviation over the square root of n. Now we're working with population proportions, so this is going to be our formula. The confidence interval has the exact same form we met in the previous chapter. So it's the estimate of our proportion, times our z star, that's our z critical, we get that from a z table, times our estimate of our standard error. So in order to find a large sample confidence interval, we first have to draw a simple random sample of size n1 from a large population having proportion p1 of successes, and draw another independent simple random sample of n2 from another large population having proportion p2 of successes. Sorry for that typo. So when n1 and n2 are large, an approximate level of our C, our confidence interval is going to be the difference in my sample proportions plus or minus our Z critical times our standard error, where the standard error SC is calculated as in the previous slide, and Z star is the critical value for the standard normal density curve with area C between negative Z critical and positive Z critical. And we can only use this when the number of successes and failures are each 10 or more in both samples. Okay, so they've got to be pretty decent. So let's go through an example. So we always start by stating our problem. Would you date a person of a different race? Researchers collected data from Match.com. A random sample of 100 black males and a random sample of 100 black females were selected from the dating site, with 75 of the black males indicating their willingness to date white females and 56 of the black females indicating their willingness to date white males. How large is the difference between the proportion of black males and the proportion of black females who would be willing to date whites? Next, we need to make a plan. We need to take black males to be population 1 and black females to be population 2. The population proportions that are willing to date whites are P1 for black males and P2 for black females. Luckily, we took 100 black males, 100 black females, so for women, P1 would be 0.75. Sorry, for men, it'd be 0.75, and for women, it'd be 0.56. Okay? And what we want to do is we want to give a 95% confidence interval for P1 minus P2. The difference between the proportions of black males and black females who'd be willing to date someone who is white. So let's look at the counts of successes and failures in these two samples. So we find our P1 to be 75 divided by 100, which is 0.75. P2 is 56 divided by 100, which is 0.56. Right, I'd calculated that. We can go ahead and find our standard error, which is P1 hat times 1 minus P1 hat plus P2 hat times 1 minus P2 hat divided by N1 divided by N2. We substitute in our values, and we find that we have a value of 0.065. That's my standard error. So now that I know my standard error, I can build my 95% confidence interval for P1 hat minus P2 hat times Z critical times the standard error. So I'm going to have 0.75 minus 0.56 plus or minus 1.96. This is the Z critical for the 95% confidence level, plus times our standard error, which was 0.0659. So I get 0.19 plus or minus 0.13. So that would give me 0.06 to 0.32. So we conclude that we are 95% confident the percent of black males willing to date white women is between 6 and 32 percentage points higher than the percent of Black females who are willing to date white men on comparable internet dating sites. So even with the samples of 100 in each, though, this interval is really big, 6% to 32%. That's really big, so you may want to pick a larger sample in order to get a smaller margin of error, in order to have a smaller confidence interval. That would feel more significant.